Wow, hi everybody. Wow, I'm so excited to be here again and present my talk to you, which is Talk to Your App. So let's start. How are you doing? How is the conference so far? Yeah, is it good? Okay, great. We're already almost in the end of the conference of AngularConnect, and like I said, I'm super excited to be here. It's been very, very interesting so far. So, just a little bit about myself. So, I come from Israel, and I'm a front-end developer, consultant, and trainer. I'm self-employed. Like Naomi said, I'm the founder of NG Girls, and we've had a really, really great event on Monday. This is the picture from this event, and if you'd like to help us out with that and help us organizing or be a mentor, or if you know anyone who's interested, I'd really like to know about that. So let's talk to our app. Well, let's go back in time, first of all, and see how it all started. Well, the first computers got instructions from us with punch cards, right? Do you remember that? Anyone remembers that? I don't think so. Well, my father, he knows these punch cards. But today, we have the main way of communication with our computers, which is the keyboard and the mouse, of course. So the keyboard is used to type in commands and also search phrases. And of course, it's also used to write text, emails, documents, things that humans read. But if we want to interact with the computer, so also the keyboard and the mouse are the main ways to do that. And if the command has a visual representation, such as a button, then we use the mouse to click on it. And with the touch screens that we have today, everything has a visual representation, and this is the main way that we navigate through the application and perform actions. But still, the most natural way for us to communicate as human beings is what I'm doing right now with you, using voice, talking. This is the fastest, most immediate way to pass a message from one to another. Face-to-face, or with recent technologies, also to remote destinations using the phone, radios, and so on. The internet, of course. So, if we could just talk to our computers, right? Well, and aside for it being a more natural approach for us to communicate with our applications, there are some specific use cases where talking to your computer is actually very beneficial. So, what are these use cases? Just a few examples. Instead of manually filtering data using many controls for all the filters, parameters in this application, it is much, much faster and easier just to say something like, give me all the transactions in the past 10 years in our London and New York sites that exceed 10,000 Satoshi. Who knows what Satoshi is? Okay, it has to do with Bitcoin. I think hundreds of millions of Bitcoin. Imagine the form that you have to fill out just to get this information, just to get this data and in the visual representation that you want. So it's much, much easier just to say what you want to get. And another use case is to allow people who are less computer-oriented, like my mom, for example, to use the application. So, for example, if I have an application of a family tree and I want her to help me to construct it, then it will be much easier for her just to tell the relations of the family and between the family members instead of going on and selecting nodes and modifying them and entering text and in the graphical representation that we have on the screen. Okay? Even though it might be intuitive and easy for us, for a lot of people, it's just not. And of course, the most common use case that we all encounter very often is when our cat decides to be super nice, or perhaps super needy and attention demanding, and he or she just climbs either on our hands or directly on the keyboard. So we really need to have some other way to communicate with the computer in this use case, right? It happens too often. So of course, this whole idea of talking to our computers was already imagined at the same time as people started imagining computers and robots. So it seems so natural. So people who come from the future expect our present computers to be able to listen to us, right? So they just try to talk to them. But it doesn't really work because he's talking to the mouse here. And so we got right away to work on this and to implement this new interface. And turns out that as natural as voice and speech may be to us, translating and transforming them to something that computers can understand is not trivial at all, right? So I believe you've probably noticed that we're already halfway there. Yeah, the future is here. Computers can react to our vocal commands and analyze what we say. We've got plenty of devices and applications that make use of this interface. And the way it has become possible is mainly by technological advancements, which enable us to store and analyze massive amounts of data, of samples, so we can just let the machine learn from them. And yes, this is, of course, what we call machine learning. So why are we only halfway there? Mainly because now it's our turn to use these abilities and in the applications that we develop. As developers, we computer engineers, product designers, we have the power to advance and improve the technologies by using them in our products. We have the power, so where do we start? So there are various options for integrating voice recognition and analysis in our application. So you can develop for Google Assistant, which is used on Google Home and Android mobile phones. And there's Amazon Alexa and IBM's Watson, and there are more options, of course. And I will show you just a few ways that you can integrate speech APIs in your web applications using the browsers and cloud services. So to be able to give vocal commands to your application, it has to be done in 2 steps. And the first is transforming your voice into text. Then you take the transcript and analyze it. You look for certain words which imply the intent, and others which will be the parameters. For example, give me all the talks giving in AngularConnect. So if your app holds the data about different conferences, the intent will be providing a list of talks, and the parameter will be the name of the conference. But the application also should recognize whether some data is missing, and it can ask for more details. For example, AngularConnect was held on 2015, 2016, and 2017. So which year are you interested in? And you have to reply. So let's begin with our first step, voice to text. So did you know that some browsers already implement this ability in their API? It's been there already for a few years. Chrome and Firefox can give you a transcript of your speech, and not only in English, but in many different languages. And the way it works, they actually use the operating system's ability to do that. And the API is simple and has various abilities. So this is the way you do this. It's really, really simple. This is the code, the basic code. So you have to, of course, support both Chrome and Firefox. So in Chrome, it's prefixed with WebKit. So you have the speech recognition class, and you create an instance of it, and it has various events, not only this event unresolved. So you can pass callbacks and decide what to do with them. So the unresolved event gives you, the unresolved callback gives you an event that holds the data of the transcription. And it also has a number between 0 to 1 that tells you the confidence that it has. And to start it, for example, with a button, you just have to call recognition start. Now, there are some things that were supposed to work also there, that were supposed to be in the API, that are in the, well, it's still an experimental technology, so it doesn't work very perfectly. For example, in Chrome, there is supposed to be the ability to give the speech recognition list of words, which will be the context of your speech. So, for example, if it doesn't recognize names, or maybe it doesn't recognize the word Angular, so we can pass it, so it will be able to recognize it when we talk. But in Chrome, it just doesn't work. So there are some things that don't work yet. Okay? Also, it's a bit harder to make it work in Firefox. And of course, in other browsers, it's just not there yet. Okay, so, but we still can use it wherever we can. And there is a great library that can help you take it to the next step. So, for example, this great library is a very known one, which is called ANYANG. And you can give it a sentence structures with placeholders for parameters and map them to functions in your application. Okay? And of course, it fallbacks to doing nothing if you don't have this ability in your browser. So, and by the way, another great feature that is also implemented in some of the browsers is the other way around. You can make the browser talk back to the user. You can use the speech synthesis API to synthesize voice from text. So this may be powerful to most applications, and it even works offline. But you know, sometimes we need something even more powerful. So first, we want to have this working also in other browsers. And also, we want to support more languages, because the browser supports something like 50 or 70. And there are many, many more languages out there. And third, we may want to rely on a consistent service and not an implementation of an operating system that we are not familiar with. So Google Cloud Speech API gives us an online solution for this. And with a very straightforward API, you pass audio and some configurations and get back the transcription and additional information. So we also get the value of how correct it thinks it is. We can pass short audio files for synchronous analysis, longer ones for asynchronous analysis with the option to receive intermediate results, and we can also pass audio streams. So let's see how it works very shortly. So we have the library that we can use in our backend, Google Cloud Speech. And here we're using the file system to also fetch the file and transform it. We'll see this in the next slide. And we just create a new instance of the speech client with our project configuration, our project ID. So this is the file. We need the file name, and we fetch it using the file system. And we pass it as a string in base 64. And then we have this configuration object, which composes our request to the Google Speech API. And so you send the audio, and you send configuration such as encoding, the sample rate in hertz, and the language code. So we have over 110 languages and variations at this moment. So you send this to the to Google Cloud Speech API, and you get the response back, the results. You get the transcript. So, and of course, it's a promise, so you can use then and catch for errors. So, more things that you can do with that. You can send a URI of an audio file and not the file itself. You can specify the number of alternatives that you have, that you want to get. If because the recognition is not always perfect, and it might think about some other ways to have the transcription. You can stream the text results if you're using the asynchronous methods. Then you can have intermediate results as you speak, as you pass the recording. It handles noisy audio, so you don't have to care about that. It strips away the noise. You can add a list of words to it, so this works here. And a really, really great feature, I think it's a new feature, is that it gives you timestamps of the words that it recognizes in the audio file. So if you have a transcript of a very long audio file, it can be also a video. So you can, for example, very easily click on a word and just jump to the place in the video or in the audio where this word is being said, and listen to the audio from this point on. So that's I think it's a killer feature. So if you're using Firebase, we can save the audio files in the cloud storage and use Firebase Cloud Functions to pass the file and to call to the Google's Speech API using a trigger that's listening to the changes on your storage. And Firebase Cloud Functions integrate with the Google Cloud APIs. So all you have to do is import the proper libraries and call the desired methods. Then you can save the results in the database. And of course, if you're using Angular for your front end, and I think you are because you're here, so you'd like to use Angular Fire to communicate with Firebase and leverage the strength that we have in Angular, such as RxJS and other features that Angular has. So you just have to install Firebase and Angular Fire 2 and start working with them. And we can trigger the Speech API also using other hooks on the Cloud Functions, not only the storage. For instance, we can first save the new file name that we have in the database, and this will be the trigger. The new entry in the database can be a trigger for Cloud Functions. And you can also use the new database that Firebase just released, and it's in beta, which is called Firebase Store. So you can decide which option you'd like more, the real-time database or Firebase Store, in which you manage your data in collections and documents. And now to the next step, analyzing the text. So again, of course, Google provides powerful engines that achieve this using machine learning. The library has different methods that you can use depending on the data that you'd like to receive. So in our Firebase application, we can trigger the text analysis function when the transcript from the speech API is written in the database, like I said before. So this can be a trigger to a new function. And we get the result back as a JSON and add it to the database. And you can also use this, just this API without the speech analysis, the transcription, to analyze written text like feedback from your users and customers, and articles and more. Any text, short or long, that you have. So this is the JSON that we're getting. And looking at it, trying to figure it out is perhaps more natural for our application and the computers, and not to us as humans in this case. But we can see a few things that we receive here. So we get the sentiment. This is a very powerful feature, whether the document, the document as a whole and each sentence is positive or negative, and how strongly positive or negative it is. So if it's a review, so if it's a positive review, or if it's a negative one and it comes from a very important customer, then maybe you might want to respond really, really quickly to it and to get these reviews popping up on your computer as they come. You get, of course, the language, and you get a breakdown to the sentences with also the content and sentiment for each sentence by itself. You get entities. So in this example, this is the example that we have on the Google API page. One of the entities is Google, and it gives us what it is. It recognizes some data, some information about this entity, and if this entity also has a Wikipedia page, then it will give us its URL, so that's really awesome. If not, then it just doesn't give us a URL. And so looking at it, like I said, might be, hard to understand what's going on there. So here in the Cloud Natural Language Process service page, this is a screenshot from Google's web page. We can send text directly from here to analyze and to see the results in a graphical way, in a visualized way, and understand the API a bit better and its abilities. So as you can see, we can have the entities with links. We have the sentiment as the whole document and for each sentence. And we also have syntax. So we can see the dependency between different words that we have in the text, the phrases, parts of speech, and so on. So you can really learn a lot about it. And there are a lot more services that you have in the Google Cloud platform that you can leverage to analyze your data and your audio files and your images and your videos. And there's so much to do with that. So one of the things, for example, is you can translate your text also using a very, very simple API. So this is actually the same translation that we have in Google Translate. Now, just a cool thing to know, the first generation of Google Translate made the translation word by word. So sometimes the result would be awkward. But today's generation is a neural machine translation. And it looks at the surrounded context as well, which significantly improves the quality of the results. So Also, Google services keep on improving, so it's really great. And Google's natural language processing service is great for many simple use cases, as well as more elaborate tasks. And you can use it, for example, to analyze different scientific and articles and extract data into one model, or perhaps a more relevant use case for us developers. We can analyze a whole specification book of the product and extract the details from it to a formal representation, which will help us find gaps and contradictions, or even transform them into an Angular CLI commands, and which will automatically build the product for us. So for more simple text analysis with a variety of options and simple use cases, we can use Dialogflow, which is formerly known as APIAI. Now, I don't have a lot of time to dig into this, but it's a really, really great service, and it's free. And it's, of course, was acquired by Google a year ago. And it provides you a simple text analysis, which you can configure with their very, very friendly API user interface. So you provide examples for sentences, and it extracts the intent and the parameters. And using machine learning, it can detect variations of these sentences. And you can configure the next step, what to do with this sentence, with this intent. And it can also ask for more data and keep the context that you're in. And of course, it can trigger an action, such as an API call using REST. And it easily integrates with existing services such as Google Assistant, Facebook, Twitter, Slack, Twilio, Telegram, a lot more. So for use cases that you don't need heavy analysis, or you'd like to be able to easily configure a conversation flows with the end actions, so this is a really great solution. And there are more applications out there that use also their own data sets and machine learning algorithms to perform analysis on voice in different ways. So I'll take a bit more of your time just to introduce a few interesting ones, which is, for example, one is beyond verbal, and they research voice samples and try to detect moods and feelings according to the pitch you're speaking at. They found out, for example, that when people talk about love and if they feel love, they talk in the F note, in fa. And when they talk, sometimes they talk from D, from re, so that's more about lust. And they provide even an application for you to analyze and detect your moods during phone conversations. So you'll know who it's best to talk to, who you should be more in touch with, because these people make you feel happier, or maybe some people will make you feel sad or angry. And another great example is Voiceit, and they give an understandable voice to people with speaking disorders. And if we're not used to conversing with people with such a disorder, it's really hard to understand them. But amazingly, the app recognizes the user's vocal pattern and gives a very clear result in text and in synthesized voice. So there is a lot more in the future. There is more work to be done on machine learning and more things that the computers can give us automatically using machine learning, but we have to work for that. And please remember to always give your users also the option not to perform actions in the more quiet way, so that they don't interfere in the middle of a concert or have to reveal their actions in the app to everyone surrounding them. And also remember that the microphone listens to everybody, everything near us. So also other people who can also say commands and say things that might be relevant to our application. I also really recommend looking at the YouTube channel of Google Developer Days that was just in September in Krakow. And there are some great talks about the machine learning APIs and about Google Assistant and what you can do with that. So take a look at that. I was really inspired there. So thank you so much again. Thank you for having me. And you can write and reach me out in these ways. And I've had a pleasure. I hope you're enjoying this too. Thank you.
Thank you so much.